Well, howdy, and welcome to Solving Exponential Equations. We've already learned how to solve these pretty much, except what if you can't do the trick that we did back in the old days? Like, look at this guy here. I look at this. This is an exponential equation. I want to solve for x. But there's no way I can build up something with the same base, and it's still equal to 3 and a 5. Like, what if you just can't do that? It would have worked great if this was like a 4 and an 8 or something. I could have gone 2 squared and 2 cubed. But I can't do that here. So what am I going to do? Well, now that we know about logarithms, we have a really good, easy approach to solving these more complicated exponential equations. In fact, what we're going to do is we're going to take logs of both sides. So when you do that, and we're probably going to use log base 10, keep it pretty simple. So they're logs with the same base, common logarithms, and taking logs of both sides. It would be no different than squaring both sides or square rooting both sides or adding 10 to both sides. Here I'm taking logs of both sides. Now, why am I doing this? Because, see these exponents? I can bring them out front. It gets the exponents down on the ground. And so look what I now have. I have x times log 3. And log 3 is just a number. Now, the right side's a little more complicated because I have 2x minus 5 times log of 5. Okay? And remember, log of 5 is just some kind of weird decimal number, most likely, but it's just a number. So how would I continue to try to solve for x? Well, on the left side, I got this, x times log 3. And on the right side, I could actually distribute the log 5 into the brackets. What I'm going to do is expand out the brackets here. Now, it's going to look messy, but really what you have is you have 2 times x times log 5. And then you have minus 5 times log 5. All right? Now, how do you continue? Well, the next approach is to get any term that has an x in it. And there's a term on the left with an x in it and a term on the right. And we bring those on the same side of our equation. So I have x times log 3 minus 2 times x times log 5. And that equals negative 5 times log 5. So it's looking messy, but it's very logical. Now here, the trick is to factor out the x's that these terms have in common. So I go x times log 3 minus a 2 and a log 5. And that still equals the same stuff that's on the left side, negative 5 times log 5. Well, believe it or not, we're almost there. To finish this up and solve for x, I am merely going to divide the stuff in the brackets into the right side. So it's a little messy looking, but you're going to have negative 5 times log 5 divided by log 3 minus 2 times log 5. And really now it's just a matter of throwing it into your calculator. Just keep in mind you're dividing by all this stuff. So I like to put brackets around the denominator here, because if you're doing it on the calculator, make sure you put a bracket at the beginning, at the end of this stuff that you're dividing by. But if you do that and you do it carefully, you should get 3.8 as a pretty good answer. And there it is, ladies and gentlemen. It's doable thanks to logarithms. All right, I have one more example that I'd like to look at. So I'm going to clear off the screen. And this involves, what if you had a situation where you invested, say, $100, and you were told that you were getting 5%, and it was compounded annually. Keep it fairly simple. How long for your money to double? So how long till it doubles. All right, how long would it take if you put your money into the bank and you want your money to double? Well, this is no equation provided. I got to build it. So my final amount, I'd like to end up with $200. See, I want my original starting money of 100 to become 200. And then I got to times that by. Now, here's where I got to put in 1 plus, because it's growth, 1 plus. And my percentage of growth is 5%, which is 0.05. I don't need to divide by anything because it's simply compounded annually. And that keeps it pretty simple for my exponent. N here is simply the number of years, because each growth period is 1 year because it's compounding annually. So this is the equation I would like to solve. Now, how do I do it? Well, first of all, let's get rid of this 100. We'll divide it into the 200. Make things a little simpler. And let's combine the 1 plus the 0.05 and just call it 1.05 to the n. So I'd like to solve this equation. Now, here's what tells me I'm going to use logarithms. The thing I don't know, it's an exponent. And so to bring that on the ground, I'm going to take logs of both sides. So I'm going to go log of 2 equals log of 1.05 to the n. Now, with the laws of logarithms, I'm allowed to take exponents and bring them out in front. So now it looks like this. Log of 2 equals n times log of 1.05. Now, keep in mind, log of 1.05 is just a number. So to solve for n, I'm going to divide by that number. So here's what I'm going to end up doing on the calculator. Just take log of 2 and divide that by log of 1.05. And that's going to give me an approximate value of n. Well, I went ahead and I did this, and I got 14.21. And n is the number of growth periods, which in this example is the same as the number of years. So there's my answer. So that's how long it would take my money to double if I was getting 5% compounded annually. And that's where I am going to stop.